Bismillahirrahmanirrahim. Assalamu alaikum. My name is Jamshed Ali. My role ID is 190994. So today I'm going to show you about the introduction for assembly languages and how we can perform these assembly programming language on AVR microcontrollers. First of all, we have to understand about the assembly language programming. So the software we are going to use are the AVR Studio for assembly languages and the Proteus for simulation before performing on our hardware. So this is the some five outlines for introduction to programming in assembly. The main advantage of using assembly language that it is fast and quick as comparing to C and other languages, and it makes us capable of measuring accurate times, and use of machine code give us precise control over microcontroller, etc. So this is the basic introduction to our AVR registers. So there we are going to use 32 registers from starting from R0 to R31. So these are the general purpose registers. So this is the basic introduction about general purpose registers. So we are in AVR we are going to use 32 general purpose registers. So this is are the input output registers. So AVR is a 8-bit microcontrollers, and it is referred to the port, and each of the AVR digital input port is associated with 3 input output registers. So this port X is related to DDRX, which is the direction registers, and port X and pin X. So every port consists of 8 pins. So our port on our microcontroller is A, B, C or D. So DDR is a direction register. These are showing the direction register, DDRX0, DDRX1. It's all shown to DDRX7. So DDRX is an 8-bit register which stores configuration information from the pins of port X. The bits in the register set the data direction of individual parts of the port. Direction of each pin can be input or output. Writing a pin in the pin location, the DDRX makes the physical pin of that port on output pin, and writing a 0 makes the pin an input pin. So these are the ports on the data registers. So ports is also of 8 bits starting from 0 to 7. So these are the commands assembly languages which we are going to perform on our AVR ATMEGA Studio. So this is first command is LDI, which is used to load data immediate. So this is addition command. This is load direct from data space. This is store direct to data space, and this is input setting location register. This is jump, and this is for output and increment, as well as all these inputs are used RD destination, RZ K constant address, and Z for 0 flag, C for carry flag. This is instruction set nomenclatures. So these are some our basic codes which we are going to perform on our Proteus. So first of all I am going to show you the first code. So such as first of all we have to originate 0x00, which tells us about the next instruction and program language. So LDI is used for load value. So here we use maximum value 0xFF to our R16, and with the help of DDR bit register we set as R16 values as a output. So here loop begins. Our output port is port B, and send the R16 value to the port B, and with the help of LDI command we send the 0 to R20, and as it is it jump to the above loop L, and then after it will returns. So in this way our all the FFF value, which means 1111 till 7, sent to the port B. So when we are performing on our Proteus, so as you can see, when I am giving 1 to the input, then all our LEDs on, means all our port B inputs remains 1 1, which means 0xFF 1 1 1 1 1 till 8 8 data pin. So this is our first task. Now we are going to move towards our second task, which we have to take an input from one port and display it on the another. We have to perform it on ATMEGA Studio as well as on Proteus. So this is our basic code. So here we have to load direct to R16 register, assign value, and then assigning R17 value, and with the help of DDRB or DDRC register we have to set the value on port B and port C as a output. So this here loop begins. So we are inputting input to the pin B to the R18, and this R18 value is sent to the port C, and it will display on the port C, and after it will jump to gain to loop 1. So it will continuously sending data to port C. So now if we are going to see on our Proteus, so as I input 1 to all the push buttons connected to the port A, it will send all the data to the port B, which means IU53, IU52, 51, etc. And these all are our LEDs start glowing, means 111 is sent to the port B from the port A. So this is our basic task to perform on our Proteus. So now we are going to move towards our third task, which is we have to show the charging sequence of LEDs on any port. So first of all we have to write its code. So now I am going to show you the code. So this is our basic code for our charging sequence. So first of all we have to originate the 0xx00. So this is the main function. We have to store 8 to the R16 and then 8 to the R18 and 1 to the 19 and 1 to the 20, and then maximum value to the R17, and this R17 value is stored with the help of direction register to the output as set as output to the port A. So here our loop starts. So first of all we have to set the R9 register 19 value to the port B, and then the R19 register value add to the R9 register 19. So and this total addition of register 19 value is then stored to the R20. Here we call some delay. After some delay it will decrement R16, means our R16 value is 8, mean this loop will begins till when branch not equal to 0. So when this loop begins 8 times, means after every decrement this will jump to the loop. When here is value is 8, this function calls, and when his variable is 7 it will also come to loop, and then when this decrement is 0 then it will move towards our next function, which is branch not equal to, and then after some calling some delay. So this is our delay function. So here we have to load direct 555 to R17, and then with the help of R18 decrement here we stored R18 8. So this loop is also begin 8 times. So after it our function will return. So now if we are going to see on our Proteus, so now you can see here the charging sequence. First of all our data pin 9 is set to high, and then after it our data 2 set to high, and then data 3 and data 4. So as it is when our 4 data pin is high, after it some delay our all the pins connection all the outputs becomes 0. So one by one it becomes on. So this is the main charging sequence simulating on our Proteus. So now we are going to perform our task for which we have to take two values from different ports and compare them. If both the values are same, then we have to show this on third port, and if not equal then we have to show this on uh, uh, this third port. So first of all we have to simulate on ATMEGA Studio, and then after it on Proteus. So first of all we have to write code of it. So now you can see here, first of all I am assigning 0xx to R20 and 0xx0 to R21, and with the help of direction register we have set the output to the B and C, and after then assigning maximum value to the R25, and then this value is showing to the DDR-D registers. So after load LDI command, when giving this value to the R22 register, and this value is giving to the R16 register. So here loop begins if increment to the pin C and IN to the pin B. So our pin C value is stored in register 17 and pin B is 18. So with the help of this command as SUB, it will compare our R17 and R18 values. So after comparison, if they are equal, then our branch not equal to next, and if it is equal, it will display the R22 value, and if it is not equal, then it will display R16 value. So when this command will turn true, branch not equal to, then it will jump to this out command. So R16 value is shown to the port D. So this is our next command. If equal, then our R22 register value is shown on the port D. So then after it will again jump to the loop 1, so it continuously repeats itself. So now you can see here, if I am giving only 1000000, and here 0000000 means both are not equal. So here I have to show 11001100. So if I am giving here all the zeros and all the zeros, then it will show 0011 00 and 11. So but in this case both the inputs are not equal, so that's why here I am showing 110011 and 00. So this is our the task 4. Now I am going to move towards our task 5, which we have to just show about these commands we are using or not. So these are our basic commands. CUM used for complement, and INC used for increment, and LDI used for load direct intermediate, and DEC for decrement, ADD for addition, and MOV for moving data, and STS from store to space, and then SUB from subtracting, and then JMP from for jump again and again for our loop or something. So now this is our task is which we have to show the traffic light system. So first of all, we have to apply on ATMEGA Studio, and after it we have to show on Proteus it working or not. So first of all, I am originating a 0xx00 value, and then setting high value to the register 16, and then register 16 value is set to the port A, B, C and D with the help of direction register. So this is our loop 3. So after it our loop 3 begins. So 0 is set to the port A, and then it clear bits, and then port A is clear, and after it 2 is sent to the port A, and after it 0 is sent to the port B, and 0 is sent to the port C, and then 0 is sent to the port D. So means so only port A is showing 2. So after it will call some delay, and then after port A 2 is going to clear, and then port A is setting 0, and then port B is setting 0, and then port B is clearing 0, and then our port B is set to the 1. So now in this case our port B is set to the 1. So after it will also again call some delay, and then it will clear the our port B, and then set to the port B 0, and then clear the port C, and then set the port C to the 1. So after it will call some delay, and then clear our port C, which is previous output, and then set to the port C to the 2, and after it will again call some delay, and then clear the port C and clear the set the port C 0, and then clear the port D, and then set the port D to the 1. So again after it will call some delay and wait here, and then clear the port D and then set to the port D through the 2. So in this way, this function again clear the previous clear the bit and set to the next bit. So first of all, it cleared the bit, such as if we are performing on the port C, it will clear the port C and then set to the port C to the value 1 or 2. So in this case our traffic light system works. So again and again it will jump to the loop 3. So this is our common delay function for 1 second, just for 1 second. Here we stored R64 to the R16 value, 200 to the R17, 250 to the R18, and then this loop begins. No operation, NOP used for no operation, then decrement. So this loop will begins on 64 times. So 64 times this 200 250. So it means for 1 second it will this loop will begins for 14 times. So this is our traffic light system. So you can see here, when our road A is set to the green, then our all the roads are set to the red. When our road A is set to the yellow, then road B is going to set on the green. But when road A is red, and then this our port B is set to the green, and after it, when it is set to the yellow, means this port turns yellow, and then this is going to green but not green. After when port B is going to red, then this port C is then set to the green. So in this circle our loop 3 is begins again and again. So this process continuously shuffle here. So green yellow red, green yellow red. So in this manner it will turn on and on continuously in a circle. So this is our basic traffic light system. So in this lab we have to learned about our useful commands which we are using in ATMEGA Studio, and we have performing some task, and how can we store values in register, in how can we give input to the port and can get output from the ports, and then we perform the charging sequence task. Here we can see how charging sequence works when we are using machine languages, and by the help of these machine language we are performing the traffic light system. So that's all from my side. Jazakallah.